Hi, welcome back to the continuing lecture on net capital budgeting. This is Dr. Jeff Fong again. Well, since our last segment of the video, or our last lecture, we've been talking about the problems that can arise from net present value and internal rate of return methods, and we already talked about the problems of internal rate of return. Of course, the problem in internal rate of return is not really in practicality, is not really a big issue because it's only a theoretical issue. In other words, the order of the equation, right? Depending on the order of the equation, you could have multiple solutions. But then, multiple solutions would be the question of negative or positive solution to, in other words, finding, you may encounter negative IRR and positive IRR because of the math. Theoretically, in math, you can have you would have two solutions for x in the second order equation, right? And in the third order equation, you would have you possibly have three different, and in the fourth order, you can have four different solutions. But as I said, it is of little practical value, little practical significance, because if you get negative internal rate of return, first of all, that is such a project will be dropped, right? Nobody will select a project that would give you a negative return. And also, negative return can happen when there is a multiple change of algebraic sign in the cash flows. What that means is, at time zero, we have negative cash flow because that's cash outflow, right? And then from then on, in the future, it will be always positive cash inflows, right? But sometimes you can still have, if you are extending a project, right? After, for example, year 5, you either, extend the project or expand the size of the project, and there will be another injection of capital. In other words, there will be another cash outflow, and there will be another negative sign of the cash flow, and based on that, you can possibly have a positive rate of return and a negative internal rate of return, but in reality, although theoretically that can happen, but in reality, even if that happens, you're not, going to take that as the internal negative one as internal rate of return, right? And so that question was, of little practical significance. The second issue, right, is with the net present value. I mean, net present value by itself has no problem. I mean, that's not the question. The question is, what if you have two conflicting results, two conflicting answers from internal rate of return and net present value? So what does that mean? And we already talked about that in the last. If net present value and internal rate of return give different results, then you go for net present value. And that kind of conflict can arise if the net present value profiles of each project, respectively, cross in the first quadrant. So if you have two projects, right, which are mutually exclusive, competing and mutually exclusive, and if they give different results, in other words, internal rate of return prefers project A, but net present value prefers project B. What do? I said, you go for the net present value. But let me give you an example. We should so this is the case we're talking about. So there's project A and project B, and its NPV, net present value profile of project A is like this. Slope is flatter, and the NPV profile of project B is a little steeper. But that means internal rate of return of project A is higher than internal rate of return of project B. Of course, because horizontal axis is the return, the rate. And if the cost of capital is this, right? Net present value of project B is 0. If the cost of capital is this, net present value of project A is 0, right? Whereas, if the cost of capital is this, NPV of B is 0, but NPV of A is positive. If this is the case, NPV of A is 0, but at that cost of capital, NPV of project B would be negative, right? But our cost of capital, you don't necessarily think about it. Cost of capital, if the cost of capital is here or here, that means very high cost of capital, right? It only makes your NPV 0, right? But if the cost of capital is lower than IRR, your net present value would always be positive. Suppose you picked K2 as your cost of capital. Now, what do you see? Of course, IRR for project A is higher. So by our internal rate of return, you would prefer project A. But look at the net present value, right? Project B's net present value is higher than project A's net present value. So internal rate of return and net present value give conflicting results. So what do you do then? Then you go by net present value. So then project B is selected if cost of capital is K2. But let's see if what happens if cost of capital is K1, which is much higher cost of capital than K2. And in that case, net present value of A is greater than net present value of B. So there's no problem, right? The internal rate of return, the selection criteria of internal rate of return and selection criteria by net present value, they both concur, so there is no problem, right? But if the cost of capital is K2, then both criteria are in conflict, so then you go by net present value. That's what it is. Okay? So these slides are something we have already done on Excel, so we're not gonna. We'll just skip that. That's not really necessary. Now then, the profitability index. This is something out of 4 capital budgeting methods, techniques, payback period, right? Net present value and internal rate of return. The fourth one and the last one is profitability index. But once again, profitability index is simply the ratio of present values of all cash inflows and present value of cash outflows. In other words, it's a variation of NPV, a ratio of the present value of a project's inflows to the present value of project's cash outflows. You understand? So you divide all the, in other words, so these are all cash inflows, right? Present value of all cash inflows. You divide all those present values by cash outflow. And cash outflow is already in present value because that was at time 0. So this is the ratio between present value of inflow, cash inflow, and present value of cash outflow. Okay? So obviously, the ratio should be greater than 1, right? Nobody would accept the project that has a ratio of negative ratio, negative number. And what if it is 0? That means the project has just 0 net present value, right? Of course, it has to be positive to be accepted, right? Okay, so that's decision rule. If profitability index is greater than 1, except if it is standalone project. But you may have mutually exclusive and competing projects, then of course, whichever gives you a higher profitability index, that will be the one selected, right? Again, with mutually exclusive projects, the two methods may not lead to the same choices. Well, we'll have to make up but I don't think we need to have an example for that. But because more crucial issue is, what if so far we've been only comparing the projects that have equal lives, project lives, right? But that's not necessarily the reality, right? In reality, the mutually exclusive and competing projects may have different project lives or unequal project lives. Then what do you do? So then we have two techniques to compare those two. Why? Now let's think about it. Um, the problem is longer-lived projects almost always have higher net present values. Of course, if the project life is longer, there will be longer period of um, cash inflows, right? It generates positive cash inflows for more periods. And then, of course, the net present value will be greater in that case, right? So that goes without saying, right? All right. So then, if you don't consider this unequal length of the project, then you would always choose, longer lived projects, right? But that is not clearly that's not fair, right? That's not uh, rational. So how do you reconcile this difference? Well, there are two methods, two techniques. One is replacement chain method, and the other one is equivalent annual annuity method, right? Replacement chain method and equivalent annual annuity. So let's take a look at an example. Which of the following mutually exclusive projects should a firm purchase? Now we have two projects. One, short-lived projects, which has 3-year project life, and the other one is long-lived projects with 6-year project life. And the short-lived projects are this is the cash flow at time zero, initial investment of 1.5 million. Everything is in thousand, right? Remember, we can just consider that $1,500, but that's just very pedantic, right? We'll just assume more realistic uh, cases, right? So if initial investment is 1.5 million, and then cash inflows from year two to three, that's like an annuity of 750, right? Every year 750, 750, 750. Okay, and if you calculate the net present value, it comes to 432, and the internal at 8%, both of them at 8% discount rate, and internal rate of return is 23.4. Long-lived project, net present value 867, but internal rate of return is 18.3. So, well, how do you reconcile this difference? Look, if you go by the net present value, then longer project is your choice. But look at the internal rate of return. Then uh, shorter lived project is what you would pick, right? So we will need to evaluate it by first replacement, right? Uh, Replacement chain method, and then equivalent annual annuity method. Now, equivalent replacement chain method is like this. Now, if you think about it, the short-lived project is originally a 3-year project, right? But if you are replacing it with suppose you're repeating this project, right? So then there's going to be another 3-year project, right? Now that means this ensuing project for another project like this 3-year project, then it will start at the end of year 3, right? Makes sense, because end of year 3 is like C0, right? So it's like C0. The second project will be, this will be time 0 for the second project, and then this will be C1, C2, C3. Make sense? Okay. So that means it will require another cash outflow of 1.5 million in C3, I mean time 3, right? So it will look like this eventually. It will look, okay. So another cash outflow, another investment of 1.5 million. So in time 3, actually it is negative, say negative 750K, right? Because there was cash inflow of 750 and 1.5 million, right? Cash outflow, right? So if you find net present value of all these cash flows, then net present value will be 776. Internal rate of return will be 23.4. So comparing that with long-lived projects, long-lived project still has greater net present value, but shorter, replacement project will tell you internal rate of return is still greater with short-lived projects replicated, right? But when, once again, we know when there's a conflict between internal rate of return and net present value, you go by net present value. So still, long-lived project is preferred. Okay. Now, if we do this on Excel, it's not that difficult. I'm going to, so let me switch to Excel. Okay. And go back and select Excel. Okay, and share Excel screen. So everyone can see this Excel. Okay, I'm trying to move. You may not see this, but I'm trying to move this sharing Blackboard sharing bar, because it's you may not see it, but it's covering the. So let me blow this up so you can see better. Okay. Alrighty. So what did I do here? Of course, this is project A and this is project B, right? Cash flow from project A and project B. So of course, I should call this okay. Let me do this. I'm gonna have to let me insert. Okay, and then let me because I want to I want to make this just t time, right? I'm going to call this time. Just give it 0. Okay, and the name, this should be I should call this C, cash flow, right? And then call this C0. That makes sense, right? Okay, and then okay, C1. All right. So then now let's think about it. What is look at this. Okay. Hmm. Yeah, I don't even have to. Yeah, this is okay. This already means cash flow, right? So I'll put the borderline later. But let's see. So K, the cost of capital, 8%. And we know in project A, right? That's the initial cash flow, right? Initial investment or cash outflow, 750, and then year 3 there is 750. But look, there, because you are replicating the project, there will have to be another, right? There will have to be another uh, cash outflow of 1.5 million, right? And then 750 in year 3, so that's negative 7. And this is present value of all of present value of. I already built it in there, so uh, if you wonder, uh, I exactly this is the definition of present value. You discount it by 1 plus k, right, raised to 1, and then you drag it down, and everything will be right done automatically. And then sum everything. That's the net present value, right? Of course, the internal rate of return. You simply use IRR command, and you'll get that. And what about project B? It's the same. Basically the same thing, right? And you understand that initial cash flow is already present value. You don't, just replicate it. You don't need to find present value. But even if I copy this formula, right, you see what, right? Even if I copy this formula, into this cell, you will still get the same result, right? The formula is there, right? But then, since anything raised to 0 is 1, it will just become itself, right? That's the idea. And then you have everything in uniform structure, right? Everything is in uniform structure. So let me put a, okay, I don't want to have a borderline here. So no borderline, and only a big borderline outside. All right. And then I want to double click on the column width so that there will be no redundant, right? Unnecessary, so that there will be no unnecessary, maybe, just. Okay. All right. So then, what's our conclusion? You get, two conflicting results, but then when IRR and NPV are in conflict, then you go by net present value, and the longer-lived project is your choice. Okay. Then what is the next one? What is the equivalent annuity method, right? Equivalent annual annuity. So let me again switch to our PDF file. And then go to, okay, I'm sharing now. All right. So then, equivalent annuity method equates each project's original net present value to an equivalent annual annuity, right? In other words, net present value of project A, which is like 432, and the net present value of the longer-lived project, 867, you use this as the present value of annuity, right? And then find what is the annuity payment, right? That would result in, the present value of these annuities, right? So this is the present value of annuity of 3-year project. This is the present value of annuity of 6-year project. Okay, and then question is, what annuity payments would result in the present value of this, right? This present value, and what annuity payment would result in this present value? And it says, well, the annuity payment for this project is, for this present value of annuity is this, and the annuity of that's a 3-year annuity, right? And this is, annual. And the annuity payment, annual annuity over 6 years would be equivalent. Would the present value of that would be this? Okay, so then what? Whichever gives you a higher annuity payment, then you go for that. So you come to the same conclusion. You get, you go for project B. But then let's do this in Excel, because it would be easier to explain in Excel. So I'm switching back to Excel. Share application screen. application window. Here's the Excel. All righty. I hope you can see this now. Okay, you see Excel. All righty. So this was the replacement chain method. And I replicated the same model here. Again, let me do this. I'll call that I just simply copied that, so copied the previous table. So let me do some housekeeping, right? It's very important to, so cash flow. I'll call this time, right? So let me okay, and this will be as I'm gonna move that there and give 0 there, and then say 0, right? And then get rid of that and drag it, simply drag it down. Ugh. Okay. It needs to be consistent, right? Center line, and then present value. Okay, so I have I have pre-built it here, but okay, now do you see? Yeah, let me put it in there and put a nice thick border line around it. Now, let's think about it. First of all, you must remember what's present value of annuity, right? From Finance 100, from the Principles of Finance. The present value of annuity formula is basically like this. Of course, if you took Intro to Finance with me, you would understand that this is not the simplest form, right? It can be simplified further, but I've been telling you that there is a benefit in using this formula structure. But mathematically, this is not the simplest. Why? Because there is a common factor, right? What's the common factor? Payment over R is the common factor, isn't it right? You can factor out this. If you factor out payment over R, this term will be 1, and this term will be just 1 over 1 plus R raised to N, right? But there's a reason I keep using this, and also if you're solving this equation for payment, because we want to know what the annuity Think about it. If our present value of annuities are, in this example, 432, right, in the short-lived project, and 876 in the long-lived project, what kind of payment will what kind of payment will result in the net present value of this, and what kind of annual payment will result in the present value of annuity of this? Well, so then question is, we need to solve this equation for payment. And if you solve this equation for payment, the equation will be like this, okay? Which is not, which shouldn't be anything new, because in 100, you learned this. Finance 100, we did this over and over. So we can, here, I already did it with Excel's built-in function, right? As you can see, I did it with Excel's built-in function, right? I'll show you again, but we'll do it in two ways. We'll do it in both using Excel's built-in function, and we'll use Excel's, and we'll also use the formula to solve for that, right? So here, I'm gonna delete that, and I see, I already found present values of all of this, so the net present value is like this, but this will be the present value of annuity for solving for payment. So here, what do I do? I'll just, the payment formula, right? Excel's built-in function, right? Enter, and you will enter exactly, right, the required variables like this. So first, the rate should go in there, and I'm going to lock it, because I'm going to, by hitting F4, you can lock it, right? And because I'm going to copy that into also to this cell. So here, and then put comma, and it's asking for n periods, and for this one, it's 3 years, right? So you enter that, and then it's asking for present value. This is the present value, but here you've got to remember, in financial calculator setting, this is the if this is the present value, that means that's the cash outflow, right? In financial calculator setting, you have to have one thing as cash outflow, and the other thing will come out as cash inflow, right? So I want the payment to come out as cash inflow, so I will have to set that as negative, set net NPV as negative. It's not a big deal, right? I mean, that doesn't make this really negative. It's just, it is still positive here. I'm just entering it as negative here. And then there is no future value, right? Because this is, present value of annuity. And then you shouldn't forget comma again, because, each comma means, between each comma, when you put comma, that means, there was a variable. Whether it is non-existent or not, you have to put a comma there, right? And then next is type. You put 0 or just leave it blank, because this is blank is the default of any. The default is always ordinary annuity, and for ordinary annuity is 0 or nothing. Okay, for annuity due, you put 1 there, but for ordinary annuity, you put nothing there, or 0. So you hit OK, you get 167.95. Okay, and then I'm going to copy that. So in other words, if you're receiving annual annuity of 167.95 for 3 years, right? The present value of such an annuity is 432.82, right? And then by the same process, and then of course you will have to make adjustment because for this one, F13 is the rate, G18 this is actually where what should go in there is N periods, right? So N period is 6, right? And then present value, J22, you make it negative, right? And then no future value. So just, nothing and comma, right? And then type, once again, ordinary annuity. So you put nothing there. Hit OK. We got 187. Okay. So think about it. By equivalent annuity, annual annuity method, project B still wins out, right? Now, once again, this is, by using Excel's built-in function. But if we use formula, right? You see this formula, right? We'll build it right there. So that you can see also the formula, right? At the same time, let me, that's too much. I guess 180% is good. So if we use the formula, then it is PVA times R times 1 plus R raised to n. One plus R to n there, right? Divided by open parenthesis and open parenthesis 1 plus R raised to n minus 1, close parenthesis. And check the formula, right? That's what it is, right? PVA times 1 R times 1 plus R raised to n over the whole denominator must be enclosed in a parenthesis, right? 1 plus R raised to n, right? E18, right? Minus 1, right? So you might wonder, oh, Professor, what happened to the outer bracket? I have outer bracket here, down here, right? Okay. But you might wonder, what about for the numerator? You don't need outer bracket for the numerator because anyway, think about it. When you multiply something to a fraction, right? It gets multiplied only to the numerator anyway, right? So without any outer bracket, I mean, there's no harm, but to put an outer bracket, but it's not necessary. And the only reason for the outer bracket for the denominator, the bottom, is because if you don't put outer parenthesis here, right, then what's going to happen? It's always PEMDAS, right? Parenthesis, exponent, right? Multiplication, division, so if you don't have another outer bracket, the whole thing will be divided by this first, and then 1 will be subtracted from that, and that's wrong. That's not what n is part of the denominator, so that's why you should have the parenthesis there, right? That's the syntax. The grammar, the mathematical grammar should be correct for that syntax, right? Correct syntax, right? So if you hit enter, oh, that's not percentage, right? It was wrong. Originally, percentage was internal rate of return was put there, so that's why you see it there. So all you need to do is simply change it to dollars, right? We got the same. Okay, and you can verify that by also doing it here once again, right? Times n or times plus r is to n, right? Which is in this case 6 over the parenthesis, and open another one. 1 plus r is to n minus 1. Okay, and you'll get, of course, if you change that to dollars, it was already, what was put in there was, percent. You got the same result. And once again, try this. If you didn't remember, in a financial calculator, right, setting, you must make one thing a cash outflow, and the other thing will come in as cash inflow. If you didn't make this negative, let's say, then you will see this comes in as negative, right? Again, this will be the same thing, but I'm not going to do that because there's no. So this is basically equivalent annual annuity method through which you can compare two projects with different project lives, right? Now, so then let me switch back to let's see this. Let me switch back to PowerPoint. So finally, so we now so we took care of the that, and this is the graphic representation of replacement chain, right? And equivalent annual annuities, right? Now, then the last topic of this capital budgeting is capital rationing. So what is capital rationing? It's quite obvious. It's the reason why we're doing the capital budgeting, because budgeting means, budgeting is eventually you'll have to ration the, the budget, right? You have limited resource, right? So that's why you're doing the capital budgeting. And either if you have $10 million and there are like 12 projects, or 10 competing projects, right? Not all of them can get the funding, right? Because if there are 10 projects, each project would be, its initial investment is, 2 million, 3 million, 4 million, 5 million, right? And how do you prioritize? In other words, how do you stack them up? right? Of course, because you have maximum budget of 10 million, right? And if the uh, 3 projects or 4 projects already exhaust the budget, right? Then the other projects cannot be funded. They will have to be dropped. But selecting those, let's say, why only 4 projects? Because one project is 4 million, the other project is 2 million, the other one is 3 million, right? That's already like 9 million, and there is only room for $1 million project to fit in, right? And we know how to stack up the projects, prioritize the projects either by net present value or internal rate of return, right? So uh, generally rank projects in descending order of internal rate of return and cut off at the cost of capital. However, this doesn't always make the best use of capital. So complex mathematical process called constrained maximization can be used. It's not really complex. But the idea is this. You have only a $16 million fund limitation, right? And there are how many competing projects? 1, 2, 3, 4, 5, 6, right? And if there are 6 projects, right, and then project A requires initial investment of 8 million, project B requires investment of 5 million, right? This is cumulative, right? Cumulative number, right? So that means, capital project B is 5 million, project C 6 million, right? D requires 3 million, E requires additional 6 million, right? F requires that would be like 7 million, right? But then what's their internal rate of return? A has the highest internal rate of return. Then that probably looks like 17, 16, 17%, 16%, and B may have 14%. C something like 12%, D 11%. So if you stack them up by in the order of descending order of internal rate of return, you can select project A and B because they satisfy, they more than meet the cost of capital, and C and D also meet the cost of capital. E and F don't meet the cost of capital, so they will be rejected. But then the problem is, although C and D meet the cost of capital threshold, C cannot be selected because it doesn't fit into our budget limitation, budget constraint, right? Instead, then what do? You kick it out. But you can fit in project D because project D is like 3 million. Oh, let's say it looks like, yeah, it's 3 million. Can 3 million fit in here? Yes, it can fit in here because our budget constraint is 16 million. A and B will be total of A and B is 13 million. So you drop project C, but you can you can include project D, I'm sorry, within our budget constraint. Okay, so this is capital rationing. Of course, if you have unlimited budget, if there's no budget constraint, we can support or fund 4 projects, A, B, C, and D, right? But with the budget constraint, it's only rational to, right, kick out project C and uh, include budget project D. All right, that makes sense? All right, so that's it for today. And I will see you guys in the next video, in the next segment. Now, since we are done with the capital budgeting, we'll move on to the next topic, which will be cost of capital. All righty. See you next time.